This is the intro video for Algebra 1, Section 4.5, and we're going to be solving systems of linear equations. We are going to do one example of this together. When you come to class, we'll do several more. Okay, so we have solved systems of equations quite a few times at this point, but now we're going to be solving systems of linear inequalities. So that means we will not be having an equal sign as our relationship. It's going to be less than or greater than or less than or equal to or greater than or equal to. We're going to learn how to deal with that. All right, so these are going to be solved graphically, pretty much exclusively graphically. So we'll get some good review of graphing lines in this. And we're going to be, in the midst of the graphing, we're going to be talking about whether the line should be dotted or solid, and we're going to be shading on the lines as well. So we've done some of this before. We did this in Chapter 3, but now we're going to be doing systems of these inequalities. So let's take a look at our example number 1. So to do number 1, what I'm going to do is I'm going to take my two inequalities, my system here, and I am going to put them into slope-intercept form. So this first one, to go into slope-intercept form, I need to subtract the x over. So that's going to give me y is less than or equal to negative x plus 3. So that's going to be the first equation in my system. And now what I'm going to do is I'm going to solve the other equation for slope-intercept form, and this one's going to be a little different. I need to subtract the x over, so that's going to give me negative y is less than or equal to negative x minus 1, something like that. But now I've got to get the y by itself, so to do that I need to divide everything through by negative 1, and that of course is going to change things. It's going to be a y, but whenever I divide both sides by a negative 1 or a negative anything, I need to change the inequality, flip it around. It's going to give me positive x plus 1. So my other inequality will go down here like that. Okay, so I feel like slope-intercept form is the easier method here, the easiest method to use with these. And so I'm going to go ahead and use slope-intercept to graph these, and we'll come up with our solution. So y is less than or equal to negative x plus 3. I'm going to graph the green line first. So my y-intercept is 3. So we're going to put that right there. And my slope is negative 1. So we're going to go down 1, right 1, down 1, right 1, etc., etc., in that same pattern. And I'll go back up this way like so. At this point, we need to decide, does this line that we're drawing, does this line need to be a solid line or a dotted line? Well, if you remember from before, because the inequality is less than or equal to, it's got the or equal to on there, we're actually going to go with a solid line. So what I'm going to do is try to draw in that solid line to fit this pattern. And we get something like that. Actually, I'm going to try that one more time. There we go, that's a little bit better. All right, so now we need to shade, and there's a number of ways we can shade here. We could try out the 0, 0 test to shade. We could look at it simply as less than, so it's going to be below the line, and that is where we're going to shade. So I'm going to try to shade this all in one shot as best I can. So shading for this will look something like that. We're going to shade on that side of the line. Now for the red line, of course, has a y-intercept of 1, which is right there, and a slope of 1. So the slope of 1 is going to show up about like this, up 1 over 1, down 1, back 1, all the way through over to here. So again, we need to make the same sort of decision as it's going to be a solid line or a dotted line. And because of the or equal to that we see in the inequality there, we are going to have a solid line. So I'm going to try to connect all those points with a solid line, something like that. And then the shading, it says y is greater than or equal to the line. And so I could test out 0, 0. I can also shade simply above the line. So I'm going to be shading on this side of the line. And so as far as the solution to our system, the solution to our system will be the region that is double shaded. So if I were to label these regions, there's 4 of them. If I were going to label these regions A, B, C, and D, let's think about which region is double shaded. And hopefully you're seeing region C. Region C has both green and red shading, and so because that's where the shading overlaps, that would be the solution to our system. You could check this by picking a point over here. You could pick any of these points in this region C, and you should be able to try them out, try any of these points out within both equations, and any points you pick out from region C should work in both equations. All right, so next time when I see you, feel free to bring colored markers or colored pencils or whatever, and we'll do some work with these linear inequality systems and do some shading and dotted line stuff when you get to class next time. I'll see you then.